Sorry, had to unplug myself earlier. My name is Chuck Meyer. I'm a security solution architect with AWS. And I want to thank you all for coming in here early in the morning on second day of a summit to talk about automation and how we can use automation to improve our security posture. Today we got a lot of different topics to cover. We're going to talk a little bit about why we're here, why we're talking about security automation. We're going to talk about the makeup of security teams and how they're evolving. We're going to talk about opportunities to do security automation, where it can fit into your security posture, when you can do it in the life cycle of applications and the life cycle of infrastructure, different practical examples of methods to implement security automation and sort of integrate it into your security posture. And then at the very end, we're going to talk about some tools and partners that can kind of help accelerate your journey if this is a direction that you're looking to go. Before we kind of dig into this, I want to just kind of level set on terminology. This is an area that's kind of got a bunch of different names, right? Some people call it DevSecOps, some people call it SecDevOps. I've heard it called rugged IT. But at the end of the day, no matter what you call it, what we're talking about is taking the things we do in our security practice and automating them, right? And integrating automation into the software development lifecycle and into our infrastructure deployments. And since we're at an AWS conference, we're going to be talking about how to do that at cloud scale, right? So why? Why automate? Well, this all kind of comes down to why we're sort of moving toward this more agile, kind of more DevOps way of doing software development and of doing IT in general, right? We want to accelerate the pace of innovation. We want to be more rapid in our mechanisms of getting new functionality, new features to our customers, whether they be internal customers or external customers, right? And security needs to match that pace of innovation. So that's what we're thinking about today. Also, we're moving to the cloud. The cloud provides for dynamic scaling. So we need to be able to scale our security function to match the scale of the cloud, right? We want to be more objective in the way we're making security decisions, right? We're doing a lot of work to set up risk assessment to figure out what level of risk a potential change might have. We're using a lot of frameworks. We want to be making decisions based on those in an objective way, and code is really good for that. And finally, we want to be automating incident response, right? Code doesn't make particular mistakes at 2 o'clock in the morning, right? Code is consistent. And that's kind of a crucial part of this, right? Is that by automating your security stance, by doing automation for incident response, we're reducing the amount of human error, right? Code tends to be effective and reliable, right? It's consistent in the way it does things. So yes, if you make a mistake when you write the code, it will make that mistake, but it'll make it in a continuous and consistent manner, right? As opposed to a person who maybe is up at 2 o'clock in the morning, is on the 4th hour of a Sev1 call, right, and has to make a decision about change to the production environment. And then even worse, has to remember that they made that change so that it could be evaluated and rolled back later. If you're using code to make those changes, right, if you're using code to make those decisions, you're going to have a better history of what happened, and you're going to be making better decisions. But of course, all that code needs to come from somewhere, right? We're still going to need humans. We're still going to be needing folks with that deep security knowledge to help us build these tools. That brings us to the who. So what does a modern DevSecOps security team look like, right? Well, the most important thing to think about here is you want a team that's going to be treated as a service within the organization, right? The whole concept of DevOps is that things sort of move into flywheels, into cycles, right? Things are kind of constantly moving. And we cannot be a gating factor in that flow. The example I like to use is Amazon itself, right? If you go to any of the DevOps talks that Amazon gives, one of the kind of the big punchlines of them, and I hate to spoil it for you if you haven't been to one before, is that Amazon now does over 50 million deployments a year, right? So you think about that, and then from a security perspective, you know, how long does it take you to do your average risk assessment, right? So we need mechanisms that are going to allow us to flow along with that DevOps lifecycle, we need mechanisms that are going to allow us to sort of work with less friction and less gating. And one of the ways to do that is to recognize that it's not just security's job to do security, it's everyone's job to do security. At Amazon, one of the ways that we get around that is we make sure that our developers are well educated in security best practices, so that not only are they coding defensively, but they have the ability to do peer evaluations of other folks' code. That's one of the mechanisms that we use to be able to scale to the amount of developers and the amount of change that's going on in our environment. So these are the kinds of things that you want to think about. The important thing here is to think about providing flexibility, right? So again, we no longer want to be a gating factor. We want to make sure that we are allowing developers to do what they need to do, to explore, to experiment, but we need to be aware of what they're doing, and we need to have a certain level of ownership of the results of that. So it becomes less about blocking and more about monitoring, evaluating, right, and making decisions as things flow through pipelines. We'll be talking a lot about pipelines today. So the team itself, what this means is that as other teams are evolving, are flowing in different directions, the security team needs to be able to adapt to that, right? So we still need folks that are highly talented in the various areas that historically security has been all about. We need folks that can talk to operations. We need engineers. We need folks that are strong in the application security side of it. Obviously, we need our compliance teams. But the thing that is often missing from the middle from security teams these days are developers. So just show of hands, who here in the room has the word developer in your title? Awesome, we've got some developers here. Okay, so who here either works within a security organization or works at a company with a security organization that has developers in the security organization? Awesome, that's great, we've got a few, that's great. Okay, that is absolutely critical. You need to have people in your security team that can both speak the language of developers, that can understand their needs, but also folks that can build the types of tools and automation that we're going to be talking about today. Right? So that's something to be thinking about. If you don't have developers in your organization now, figure out if you're going to use these practices, how are you going to get those developers? How are you going to bring them into your organization? How are you going to borrow them, maybe from a cloud center of excellence, right? But you're going to ultimately need folks that can fill that role. Okay. So where to automate, right? How do we do this? How do we take our security practices and integrate it into the things that the DevOps folks are doing already, right? We talk about 3 different places, and the first 2 are actually kind of parallel to each other. So DevOps tends to be about culture, process, and tools. And on the tool side of the equation, and on the process side of the equation, we tend to kind of focus on continuous integration, continuous delivery, and continuous deployment, right? So automated processes for bundling up code and deploying it out onto infrastructure. And that leads to sort of 2 security areas that we need to think about, right? First of all, the pipelines themselves, right? These are incredibly privileged mechanisms within your environments. Historically, they held the code, which is often the keys to the kingdom. But now, as we start thinking about infrastructure as code, these are the pipelines that you can use to deploy servers, right? To configure servers, to deploy network changes. So they're incredibly privileged pipelines. How are they getting deployed? Okay, we'll do another show of hands here. Who here has ever run a Git repository, a Jenkins server, under their desk? Yeah, me too, right? That's terrifying from a security perspective, right? As we think about how these processes evolve, if that's the server that's going to be modifying security groups, right? Or spinning up EC2 instances, right? Or even deploying Lambda functions, maybe we need to be thinking a little bit more about how are those pipelines hardened, right? Are we following security best practices when we deploy those systems that are going to be so important to the way we do business? So hardening, permissioning, right? From an AWS perspective, what sort of roles are associated with those servers? Those are things to think about. Once we're happy with our pipeline and we feel like it's a very secure mechanism for deploying our code, deploying our applications, deploying our infrastructure, we think about opportunities within that pipeline to automate some of our security practices, right? As you're building the code, what sort of validations are you doing to the artifacts? If we're pulling in libraries, where are those libraries coming from? You know, are they being scanned? Is that automated? Once we know that we're comfortable with the artifacts that we've built, are we signing them so we know that they haven't been changed before deployment? What sort of analysis are we doing on the codes, right? Static analysis, dynamic analysis. What are the tools that the developers are using now, and how can we integrate with them, right? How can we make sure that we're getting what we need out of that process as well? So just like we talk about security of the cloud and security in the cloud, when you're talking DevSecOps, security of the pipeline, security in the pipeline. So just kind of some examples just to get you thinking about this stuff, right? This is kind of a typical cloud-based deployment pipeline, right? So we're doing some CI, we're doing some delivery here, maybe not deployment. We might not be going all the way to production, but we're at least pushing out to environments, right? So your typical kind of flow here is your coders are coding, code. Hopefully they're checking everything into some sort of version control system, right? So there's a Git or something like a Git sort of sitting there. That code is then getting pushed up to a CI server that's orchestrating builds. We're taking that code, we're bundling it up, we're finding dependencies, we're pushing it into artifact repositories, right? And then because we're in the cloud, we have an opportunity to go even further, bundle that up into server images, right? Configuration management packages, deployment mechanisms, potentially build out CloudFormation templates to define environments. Take all of that, put it together, deploy out an environment, deploy the infrastructure to that environment, do some additional testing, figure out if it's okay to promote it up to the next environment, and slowly make its way up to production, right? So this is very typical continuous education, continuous delivery flow. So now we put on our special super secret security glasses, and we start thinking about where are there opportunities here, right? The very first place is between the developer and the version control system. There are opportunities to do pre-commit hooks, right? There are things we can potentially do in the developer's environment to evaluate the code before it even gets to the version control system. Has anyone here heard of a small package on GitHub called Git Secrets? Okay, so Git Secrets, it's a very small package. It's up on GitHub right now. And it's essentially just a set of regular expressions. But what those regular expressions are checking for are AWS access keys and secret keys. And you can actually hook that in as a pre-commit hook into Git so that before the code even gets checked into the repository, we check to see if there are any access keys or secret keys in that code, and we'll stop the commit, right? So we think about folks that have accidentally let keys slip into maybe a public S3 bucket or maybe up onto GitHub itself, right, in a public repository. You know, how great would it be if that code just never even got in the repo in the first place? So there are opportunities right there on the developer workstation to potentially do some security blocks. Once it gets into the version control system, as we're doing our build, obviously, that's classically a place where we can do some static code analysis. We can do some linting. We can make sure that the code is meeting best practices, right? As the packages are built and put into the artifact repository, again, opportunities to sign, validate those packages. And also, hopefully this system is generating logs across the board, right? Developers absolutely want visibility into this pipeline. As security practitioners, we want that visibility too, right? We want to be aware of what change is flowing through. We want to know what's successful, what isn't. And then as we move into automated testing, there's an opportunity there to put security tests in there as well, right? So think about what sort of test can you put into the testing framework that will match your security or your compliance needs. Okay, so security of the pipeline, security in the pipeline. This is where we cheat. I said there's 3. Number 3 is kind of everything else, right? But we kind of focus on the stuff that the cloud brings to the table. So everything I've talked about so far, that's just pure DevOps. That's just kind of CI/CD stuff. But there's some things that you can do because you're running in the cloud that are a little bit different. The most important thing, right, is treating your infrastructure as code. Using tools like CloudFormation or partner products, right, or DSLs sitting on top of different languages to define the components of your infrastructure as code that is checked into repositories alongside your configuration files and the code itself, right? This allows you to do interesting things, like split up ownership of your infrastructure, right? So maybe one person controls the security group component, and another person controls defining the servers and the application stack, right? And another person is maybe in charge of IAM roles. All of that stuff can be deployed separately or integrated, validated, and deployed together. So there's a lot of opportunities there. If you're treating your infrastructure as code, you have an opportunity to evaluate that code, the security of that infrastructure, prior to even deploying it, right? So you can look at the code and make decisions there, rather than waiting until the horse is out of the barn and it's actually sitting in an account. The elasticity, right? That's obviously another tool that you have in your pocket from a security perspective. If you're getting hit by an attack, you have the ability to scale out. If you see a server instance, right, or a piece of your infrastructure that isn't behaving the way you expect it to, it seems a little bit atypical, you have an opportunity there to terminate it, to isolate it, right, and to allow that environment to sort of heal and take over. And we'll show a demo later that kind of demonstrates some of that. From a runtime perspective, again, you have this opportunity to be constantly monitoring your servers. And if you don't like what's happening, pull it out. If something is not matching your security baseline, deploy new, pull out the old one that was vulnerable, right? Rather than patching it and hoping that no one has exploited it in the meantime. You have the opportunity to tag your infrastructure, right? So you can slice and dice it into different areas. You can tag things that are part of your PCI environment, right? So that you're aware of those particular servers or pieces of your environment that might need additional checks above and beyond what you're doing in some of the other pieces of your environment. And finally, the concept of immutable infrastructure, which often in the enterprise can seem untenable, but is actually closer than you think. With good automation across the board, right, from the developers through configuration, through infrastructure deployment, you can get to the point where you simply just don't log into servers. You don't make changes on servers. You always tear them down and build new ones. So when should you do this? We talked about we talked about this a little bit before, but the concept is this is a cycle. So you should be doing this stuff all the time. But that kind of breaks down into three basic areas again. Right? The first thing is you have opportunities before anything happens, right? Before deployment occurs. And this is the best place to do it, right? The horse is not out of the barn yet. So we want to treat our infrastructure as code. We want to be putting it in repositories. And we want to be validating. Just like we would validate our code, just like we would do code analysis, we want to be evaluating our infrastructure code. And there are just starting to be some interesting tools in the space. I'm going to share with you some open source stuff that's available that will allow you to kind of help out with this type of sort of pre-commit evaluation. But it's not just the AWS side of things, right? If you're containerizing, you've got an opportunity to evaluate your Docker containers and the configuration of those. Right? All of these pieces that are defined as code, configuration files, if you're using Chef or Puppet or Ansible, you should be evaluating these from a security perspective as well. Validate things early on. As you're building your packages, that's a great opportunity to make sure that you're aware of where those libraries are coming from and that they are secure and they're not containing malicious code. Right? Always force change through the pipeline. Right? So even if you're sitting in the middle of the night and there's an opportunity to just open up a firewall rule that might fix something very quickly, make sure that happens through the pipeline so that you've got a record of it, so that it went through the channel and that it's easy to roll it back later when you have the real fix. Right? And fail close. So if you're unsure about something, figure out a way to block it. You're not impacting actual servers. It's just the code itself. Right? So you've got a great opportunity to just block. Right? And then figure it out and quickly revise, refine, redeploy. So even if you're super confident on the pre-side, we still got to do the post-side, right? We still need to be evaluating the servers that are actually up and running, the environment in its current configuration. The cool thing is, again, remember that you're kind of living in an API-driven environment, so you can kind of monitor those APIs that are sensitive, right? People that are modifying big-ticket things, like route tables or security groups, right? Building new VPCs, turning off CloudTrail. Be aware of those APIs and make sure that you've got the appropriate controls in place around that, right? Always think of what's the best source of truth for what you're trying to do, right? Is it a describe call from an API that's going to give you exactly what's in your environment right now, right? Is it a log file? Has that log file been signed in a way that you know it hasn't been tampered with? Choose the appropriate source of truth for what you're trying to accomplish and the speed that you're trying to accomplish it at. Right? API calls tend to be faster than log aggregation. Log aggregation tends to be faster than using config. And finally, figure out what you want to do for remediation. And that's an important piece because what we want to get to is we want to get to automated remediation, right? So it makes sense to try and remediate to have a good playbook, but it makes even more sense to try and take that playbook and automate it. An interesting thing about being on the cloud is that it's now an event-driven infrastructure, right? So there are opportunities to hook code directly off of an API event. So if someone goes and creates a new master key in KMS, you have an opportunity to run code right then and there and do something, right? This is a great opportunity. So what can we do with that? We also have opportunities to run things on a scheduled basis. So we'll talk a little bit later about compliance frameworks. If you're running within a compliance framework and you've automated your checks for that framework, you could run that every day, right? You can make sure that that environment is compliant not just a week before the auditors show up, but every single day you walk in the door. And you can look at reports that kind of tell you where you are on that trajectory. And that kind of falls into this whole per framework basis. And I think we'll talk about that a little bit more in the next slide. But evaluating not just individual servers, but sort of the overarching architecture within the context of a framework. So some examples here, things that we can be doing. The first thing is security validation of elastic infrastructure. So this can be a big challenge, right? This is kind of one of those things that the cloud makes more challenging. Servers are spinning up. If you're using auto-scaling, they're potentially spinning back down. Are they going to be there, right, after an event has occurred? If you're doing log analysis and you notice that something weird happened, is that server still going to be up and running, right, or are we going to lose it? So there are opportunities here to have consistent monitoring so that if there is an event, we can grab that server and we can isolate it prior to it being terminated with an auto-scaling event, right? That gives us that opportunity to do our forensics, even in an elastic environment, right? The other thing to think about here is what are the opportunities here from an immutable infrastructure perspective, right? If folks can't, if that server is going to be short-lived anyway, why should anyone log into it? You know, what are the reasons that they log into it? Is it to collect log information, right? Is it to make fast tweaks? Is there ways to do that outside of the box itself? So think about those. And then again, automated incident response. So if there is a problem, if it does look like a server has been compromised, you know, can we auto-heal that? A great example of actually this sort of automated response is CloudTrail itself, right? Who here has CloudTrail turned on in your account? If everyone doesn't raise their hand, I'm going to be sad. Because CloudTrail are your CCTV cameras into your AWS environment, right? CloudTrail gives you the visibility into what is going on, what people are doing in the environment. So if I'm an attacker and I manage to compromise your environment, the first thing I want to do is turn off the cameras, right? The first thing I want to do is shut down CloudTrail. And not just in the regions you're working in, right? It's actually more important that I shut it down in the regions you're not working in, because those are the ones you're not paying attention to. So having some sort of automated mechanism to monitor when CloudTrail is turned off, turn it back on, and tell people that it happened is incredibly useful, right? So monitor the cameras themselves. Make sure that the cameras are on. And if there is a set of credentials that is trying to do this, maybe it's time to take away privilege from them and have a little conversation, right? And then the final thing that we're actually going to talk a little bit about right now is integrating with host-based solutions, right? So AWS is historically very good at giving you visibility into the infrastructure itself, but within the shared security responsibility model, we tend to kind of back away from what's going on the individual servers historically, right? But you've got good tools for that already, and you can continue to use those. And you can integrate those into the tools that we provide. There's a great meeting place there. And we're actually going to do a demo here in a second. Let me just go through this real quick. I'm going to show you kind of one way to do that. So this was something that we did for a customer that was very interested in doing immutable infrastructure, but didn't want to take away the ability to SSH onto the boxes, right? So this is, again, coming back to that. We don't want to block. We want to observe and evaluate. So they didn't take away SSH rights to the boxes. But what they do is they flag a box that's been SSH'd into as tainted. Then they isolate that box. They do evaluations. They figure out why that box was logged into. And then they can make a decision about it. Do they need to do cyber forensics on it? Do they just need to slap a developer on the back of a hand and say, go through the pipeline next time? What do you need to do? So the way we implemented this is we actually made a modification, just a small modification to PAMD to trigger a script anytime someone SSH'd into the box, anytime the SSH daemon received an incoming connection. And what that script does is it tags the box itself as tainted with a date. And that tag triggers a CloudWatch event that actually isolates the box, right? It removes the box from an auto-scaling group. It attaches a new security group that isolates it. And then, of course, the auto-scaling group itself will self-heal up to the number of instances that need to be there. So a new instance will come in and take its place. So we can isolate that server without impact to the application itself. So I'm actually going to switch over. I'm going to show you just a quick demo of how this works. OK. So this is just a little Python script that's making API calls. It's retrieving my servers that are within the auto-scaling group. And you can see here the public IP. It's part of my instance security group. And you can see the tags associated with this. So this is part of my tainted demo. So now what I can do is I can come over here. Now I'm going to SSH onto this box. Sure, I trust that certificate. Why not? So you can see I instantly got a tainted tag on my server itself. So now this box has been marked as tainted, and I can immediately see that someone has logged into it. But more interestingly, what's happening on the backside is this is going to trigger a CloudWatch event, which should trigger my Lambda function. I'll go into my CloudWatch logs here. All right, nothing yet. So what you can see here is already we've been tagged almost instantaneously. We're still sitting in our, now we're sitting in our isolation security group. So we've actually switched over. Automatically, we pulled off the security group associated with this server, and now we've added our isolation security group. So this server is now out of production, and it's sitting in a group where it can't be accessed until someone can come in with forensics tools and do an analysis, or maybe just go back and do a log analysis to kind of see what was going on right beforehand, right? But some sort of decision can now be made against this server. Let's see if that's actually, oh, here we go. So you can see found an auto-scaling instance with the tag, and we've isolated it here. So the last piece of the puzzle is my auto-scaling group has realized that that server is no longer part of the auto-scaling group. And so it's automatically spun up a new server within the security group. So production impact is minimal, right? The server was down for a little bit of time. Hopefully you've got multiple servers. Hopefully you're running with load balancers. In those scenarios, then it would have been a minimal impact to your application, that very short window between when we isolated the old one and when the new one was fully up and running, right? So that's just kind of one of the things that you can do with automation. And the nice thing is that I didn't have to make any of those decisions in the middle of the night. I've got a one-year-old at home, so I'm already making bad decisions in the middle of the night. Last thing I need to do is trying to decide whether or not to pull this server out. So now it's already isolated, and all I have to do is come in and say, oh, it's time to do the forensic side of things, right? Hopefully the production side of it is at least slightly mitigated at this point. OK, so that's my demo. We're going to switch back over to the slides now. So that's really cool, right? That's kind of the slick, fun stuff that looks great when you get up on a stage like this. But that's not the end of it, right? Think about safeguards. You've got scripts now. You've got a lot of power and ability to do automation here, right? So do your attackers. If they're doing this in an automated manner, right, they're logging into SSH instances, and your script is pulling them out of an auto-scaling group, right, and doing stuff on your side, and this just happens to, say 8 o'clock on a Friday night, right? You come in Monday morning, and this has been going on all weekend. We're still going to bill you for those instances, right? So there are other pieces to this. 50% Figure out how many instances you want to isolate before you escalate this, right? Have your automation cut tickets. When things get bad, have your automation page people, right? This is just the first part of a larger strategy. Again, we still need the humans, right? So just think about all of that stuff as you're building your automation. Remember that it needs guardrails too. This is production code. So one of the ways to kind of mature these things, right, to mature these automations, is to kind of build a structure around how you're going to do this and kind of have a consistent pattern about how your incident response is going to flow. So obviously detection is the first piece of this, but figure out what is the source of truth I want to hang off of, right? Do I want to work instantaneously off of an API call or an event? Do I need a little bit more information? So I actually want to hang back until this comes in through config and I've got a little bit more information about the dependencies. Am I more confident aggregating everything into a seam and then kind of evaluating that sort of enriched data that comes from getting it from a couple of different sources? You know, what is my source of truth here? And then what is the first priority thing that I need to do, right? Obviously, if a system's been logged into and I feel that that's enough that that system is compromised, maybe I pull it right away. But maybe I don't, right? Maybe I give the attacker a little bit of rope and I notify some folks and I monitor and I start collecting some additional logs to see what they're up to, right? What am I going to do? What's my priority here? How do I integrate with my forensics tools on the backside? And what sort of countermeasures should I take, right? How deep should this go? Do I simply do something to the resource that's compromised? Do I need to do something to the attacker, the person that is actually coming in, the credential? Do I need to disable or remove permissions from that? What do I do? And always alert, always log, right? And not just an individual, right? If I write a piece of code, it shouldn't just page me, because I go on vacation. It should be making sure that you're alerting the right folks and in the right manner. If you have ticketing systems, integrate with that. So how do we do this? Well, the good news is you're not alone. There's a lot of stuff out there. There are a lot of partners. There's a lot of open source products that can help you improve your security stance, your security posture, and can help you down the road of automation. Obviously, a lot of these folks are out there on the vendor floor. Take the opportunity to talk to them. We're not going to go through all of them right now. This is really just to dazzle you with the number. But think about it. How can I take these products and incorporate them to save me from having to write code that someone else wrote, 4 years ago and has matured significantly? The marketplace is a great place to meet these folks. We have a ton of software in the marketplace. And the cool thing about the marketplace is it follows the AWS model, right, of provision and pay. So you don't have to go out and purchase these products or do complex evaluation agreements, right? You can just go grab it from the marketplace, try it out, see if it meets your needs, right? See if it fits your security context and it integrates well with the rest of your security tools. And if you don't like it, you can switch to something else. This is a methodology that a lot of folks are using. Not just for commercial software, right? But this is a great way to procure open source tools. If you're not comfortable pulling down the code and building it yourself, you can get pre-built images, right, that have some of these open source products on them as well and evaluate those if they meet your needs. There's some really mature open source products now that you can get and sort of enhance your security posture without having to spend a ton of money, which is pretty great. And the cool thing is Marketplace also provides a lot of these SaaS providers now. So it's not just pulling down machine images, but if you have a relationship or you want to start a relationship with a SaaS product, right, you can do that through our marketplace. You can leverage your existing procurement strategies that you use for AWS to procure some of the software as well, some of these SaaS products. And the cool thing is that we are now, we've got a great partner program where we're starting to evaluate security products for cloud readiness, right? So you can actually go in and find partners, software, SaaS solutions that meet our security certification requirements for cloud readiness, right? You can make sure that you're getting products that are going to work well on the platform. So within the marketplace, again, for the SaaS products, you've got 2 different opportunities. You can do the pay-as-you-go model, right, which is kind of the classic one. But you can actually purchase licensing through our marketplace as well. So if you tend to, be a little bit more traditional in the way that you purchase your software, you can do that through the marketplace as well. That way you're not ruffling any feathers on the business side with the way you're sort of grabbing this stuff. But it only gets you so far. At the end of the day, you're going to need to build stuff. You have very specific needs. You have a very specific way of doing security. And you're going to want to build tools that allow you to do that at cloud scale. And we recognize that it can be daunting, right? You see all of these services, over 90 services out there. All of them have controls, right, of some sort, even if it's just IAM controls. So you need to be kind of aware of all the different pieces of it and how to put them together. And it can be daunting, but at Amazon, we're kind of a builder culture, and we actually find it exciting, right? This is a great opportunity. You've got a lot of tools available to you. But think about how you're going to put them all together, right? Think about sort of the right way to integrate them with each other. Think about the different flows. How are your users using the platform? How are your users using the resources that are available to them, right? Are they interacting directly with the console? Are they making API calls? Are you using CloudTrail? Are those API calls getting logged so that you know what they're up to? Where are those CloudTrail logs going? Usually it's an S3 bucket, right? Is that the final destination? Is that good enough? Can you maybe use Athena or something like that to query directly against the S3 bucket? Do those need to be aggregated up to another tool? Are you going to be doing anything in real time? Are you going to be using CloudWatch events, right, to do these real-time triggers like we were kind of showing with the SSHing into the boxes, right? Because if you are, the backside of that is Lambda. So we want to make sure that we're very comfortable with Lambda and being able to write code and inject it into functions that are going to be triggered by events. How is that code going to integrate with your existing tools? How do you cut tickets? Is there an API for that? Do you need a library? How do you make sure that that's available to folks so that they're doing the right thing when they're building their automated controls? And if you don't have a good way to talk to people right now, right, if you don't have PagerDuty or any of those things at your disposal, which you probably do, but if you don't, you can very simply use our notification service, right? That's a great way to get information out to folks via email or text messages, right? So it's good to use in a pinch, too. But make sure you're following the practices of your organization, right? Don't just be kind of going off on your own unless that's just something that needs to happen, right? So lots of tools available here, right? Lambda's a big part of this. If you're doing automation, you're writing code, Lambda's a great place to put code, right? It's great because it only runs when it needs to. It's isolated in and of itself, so there's less of an attack surface for it, right, when you're talking about security tools. And you don't have to run servers full time just to get that security stance that you need. This stuff can just be sitting out there for when you need it. You've got a lot of different sources of truth out there, right? Make sure you know them. Make sure you know how to integrate all these different pieces together. Inspector is something that we haven't talked about yet today, but Inspector is our tool that actually sits on the servers. Like I said, historically, we weren't really in the business of looking into the servers themselves, but we now have an agent that you can run on the boxes that gives you visibility into those servers if you don't have another tool or if you want an additional tool that sort of is a nice parallel or complement to what you have already, right? And make sure that you're talking to folks, right? If you don't have a mechanism, again, SNS is a great way to do it. So we talked about this a little bit already, but one of the things to think about is when you're doing automated remediation, right? What are all the pieces of that? And the great analogy here is you wake up in the middle of the night, you go downstairs, make yourself a sandwich, and you notice that the front door is open, right? So you close and you lock the front door, and then you go up to bed, right? And you go to sleep. Well, no, that's not the right thing to do, right? So you've got to make sure, okay, well, what happened after that door is open, right? You need to figure out why did that event occur, and how do I, what are the ramifications of it? How do I prevent it from happening again? There are lots of things to think about here. One of the classic things, again, we already kind of talked about this, but you have scripts, they have scripts, right? So what are the steps beyond just sort of reacting to the script that's aggressing you, right? How do you go back and how do you figure out an ultimate remediation there? And inevitably, some of these things are going to be false positives, right? There's going to be some group out there that's doing something crazy for good or for bad or for stupid, and they just forgot to tell you about it, right? Well, we turned off CloudTrail logs because we wanted to see how that would affect this other piece of our puzzle, right? Or we had to open up the security group because we're doing some sort of testing against the operating system itself, and we needed all of the ports open. And sorry, we forgot to cut a ticket, right? So being able to sort of react to those things as well and say, okay, we'll give you a buy for the next hour, or whatever it needs to be, right? Think about these scripts as production code. So make sure that you're writing them as production code as well, that you've got good error handling in them, that you've got good logging, right? Because I might not be around when my code actually triggers, and someone else might have to figure out, why we keep shutting down servers, or why we keep pulling servers out, or why CloudTrail keeps going up and down and up and down. So make sure that you're logging, right? Make sure that you're treating your code as production as well. And don't forget the safeguards, right? So taking a step back and saying, all right, 3 strikes, you're out. Your credentials are now locked. I'm pulling out the policy that allows you to do what you just did, or everything, right? And I'm cutting a ticket, and you have to come talk to me so that we can figure out what's going on. Was it you, or is it someone that got your credentials because you put it up in GitHub, right? So one way to do this, again, we kind of talked about this earlier, but is to think of building a framework, right? So think of all of the things that need to happen. As you're looking at different pieces of your playbook, as you're thinking of things that you want to automate, right? This is so brain dead. There's a real opportunity here. I can write some code that will do this just as well. Think about all the edges of that, right? Think about what's going to trigger it. Is it going to happen all the time? Is it running as a cron? Is it running in memory? Does it only need to run when something happens, off an event? What are the constraints on this thing, right? Are we going to do this thing infinitely? Are we going to do it once? Are we going to maybe do it 3 times and then escalate to doing something else? And what is the impact on the environment, right? The production environment. If I terminate that server, did that server, have transactional information, financial transactional information in memory that will never recover again, right? Is it a database, right? What are the ramifications of doing this particular action to this piece of the environment? Do we need to make sure that we've got a way to pull some servers out of scope of certain actions, right? Because there is cost associated with some of these actions, right? And then finally, making sure that you're using the right source of truth, as we talked about earlier. And then as you build the code itself, be thinking about filling in all of these different boxes here, right? What's the first thing I have to do right away? What sort of analysis do I need on the backside? Or what do I need to keep to make sure that a human can come in and do that analysis later? What other countermeasures do I need to take above and beyond just reacting to the event itself? What's the big picture here? Are we under a larger attack? Are there other things that we need to do, right? Is this part of a flood or a DDoS, or we need to maybe look at increasing the size of our auto-scaling groups, or reevaluate our CDN distributions or something to make sure that we've got what we need to weather this attack in the big picture, not just in this little picture, right? And who am I contacting on the backside? Who's aware of this, both from a learning and a logging perspective? So what else can I do? Well, one thing you can do is start being even more proactive, right? You know your security posture. Historically, you've matured quite a bit. You know sort of the edge cases of the software that you're running, of the infrastructure that you're running. But there are opportunities here to take it even a step further by benchmarking your infrastructure, right? So you might already be under certain compliance frameworks, maybe PCI, maybe HIPAA. Maybe you are using one of the more recent sort of cloud-based benchmarking tools. So the CIS now has a benchmark for AWS Cloud Infrastructure where you can actually score your infrastructure. You can go and look at different configuration settings and evaluate your security posture. And that can be automated. And the good news is it has been automated. One of my colleagues actually took the majority of that benchmark and implemented it as a config rule that you can actually download and install and run in your environment. It runs as a Lambda function and will actually evaluate your environment on a schedule based on how you have the config rules set up. And we'll look at kind of some of the outputs from that. This is the URL for it right now. It's in the slide deck so that you can grab it later too, right? So his implementation gives you kind of a couple of different ways to sort of look at the results. One way is kind of this nice HTML report, right? So you can actually have this rule set up to run on a daily basis so that when you come in the morning, this is sitting in your inbox, right? You've got a nice HTML report that kind of shows your overall compliance against the benchmark on a day-to-day basis so that you can track it. Or you can kind of push it into an automated system. So it's got a JSON output, because we love JSON. And you can take this and pull it into a tool to allow you to see where you might be weak, where you might need to have areas of additional improvement. And then for real fast reaction time, we can actually just show you the areas where you're not compliant, right? Where you have the lowest scores, or you're failing the most. So you can kind of go through and just keep an eye on this. This would be great to put up even just on a LED sign, or up on a dashboard somewhere, right? Just so you can kind of keep track of it. Okay, so at the end of the day, why are we doing all of this, right? Why are we putting ourselves through all this extra work of automating this stuff? Well, again, it's to scale. It's to scale at cloud scale. It's to scale at the pace of innovation that DevOps is accelerating, right? It's to recognize that people are awesome and powerful and can do amazing things, but we can't clone them yet. We can't scale them up the way we can scale up our infrastructure. We can't scale them up the way our application life cycles are increasing in speed, right? So by taking the tasks that are repeatable, the tasks that can be automated, and codifying them, we're taking that off of their plate so that they can do the things that humans do well, right? That can be evaluating forward, that can be looking at new software, that can be looking at new opportunities to improve our posture even more, right? Take that day-to-day stuff and push it out as much as possible. We want to do this stuff as early as possible, right? We don't want to be reactive anymore. We want to be proactive. We want to be part of the process. We want to be identifying security problems early in lower environments, and hopefully even before things are actually even deployed to environments, right? And we want to be doing this on a continuous basis. We don't want to be scrambling a week before the auditors show up. We want to be continuously monitoring and auditing so that when the auditor comes, it's just another Tuesday, right? So things that I would like you to do. First thing, start looking through your runbooks, right? Look for things that could be automated easily. Think about the things that you want to accomplish that maybe you aren't accomplishing already. Write them down in English, right? Write them down as a use case. And then figure out, how can I automate this? Is there a tool that I can grab that will allow me to do it? Is there a piece of code that maybe I already have sitting in my back pocket that I just run locally on my laptop that might make more sense to integrate up into the platform itself or into the pipeline, right? What sort of things do I have already? What are the low-hanging fruit? You don't have to boil the ocean here, right? You can start with very small things and just slowly sort of work your way through. It's about developing a process that you can mature and then allow you to accelerate the way that you're sort of automating your security posture, right? And how can I validate the things that are going on in my environment, right? So this isn't just about responding to incident. This is about sort of continuously monitoring. Are there frameworks that I can hang off of? Have those already been codified? If not, how do I codify them? Are there businesses best practices that I can codify, right? How do I make sure that not just the right things are being done during deployment, but that those environments are consistently meeting my criteria for security? Okay? So those are the takeaways. Go and find one thing, just one thing, automate it. Here's some open source tools that can help you out. We talked about Get Secrets already. It's a very small piece of code. I find that it's most effective if it's running as a pre-commit hook for Git, which means that it needs to be running on the developer desktop, right? Which means you either need to have the developer voluntarily install it, or you need to have some level of control over how those desktops are deployed. But it really helps everyone. Access keys and secret keys getting out into the wild are a significant factor in security incidents on the platform. So stopping that from happening in the first place is great. And the earlier you can stop it, the better, right? The AWS Security Benchmark, that's that implementation of the CIS benchmark as a config rule I was talking about. Recommend, if you are in a position that you can run config rules in Lambda in your environment, grab it, run it, see how you do, right? There are plenty of other config rules out there. We actually keep a curated library of community rules that have been written that we think are useful to our our AWS community at large. So if you go up to the AWS Labs and you go to our AWS-config-rules folder, you'll find a bevy of different rules that folks have written. Those rules are updated, matured. So it's a great place to kind of start, grab some code, maybe grab some rules that you want to run, or maybe just grab a couple of rules that do something similar to what you want to do to serve as a baseline to kind of level you up a little bit. Some of our customers have released some of the things that they've done. Netflix is obviously has a bevy of open source tools, some of which kind of supplant other open source tools that they've had in the past. SecurityMonkey is part of their Simian army. It's been around for a while. It does some really cool things. They've done some cool things about server access now with their Bless open source product. There's ETA. So there's a lot of things there within the Netflix code repos that you can look at it and potentially use or exploit. Threat Response is a great website that has a lot of incident response products on it, open source products. So it's kind of a clearinghouse for different tools. Some of them have very interesting names. If you want to find this site quickly, just do a Google search for Margarita Shotgun, and you'll find it pretty quickly. And then Stelligent has some really interesting things that they're doing on their side. CFN-NAG is a tool that they've written for linting, evaluating the security of CloudFormation templates using JQ. So it's a framework. You can write your security rules as JQ queries. And then what it will do is you can actually hook this into your build process so that it can evaluate the CloudFormation and make decisions about the security of the CloudFormation before you deploy the resources. So CFN-NAG is a great tool for that. And then Capital One has released a framework called Cloud Custodian. This is a security framework that hangs off of CloudWatch events. So they wanted an ability to respond very quickly to events in the environment, right? And CloudWatch events is a great place to do that because you've got almost instantaneous ability to trigger code based on an event in your environment. So this is a framework that kind of gives you all of the groundwork for doing that and allows you to, it's got some pre-written rules in it, but it also allows you to kind of build your own rules around that. So CloudWatch events are interesting, right? Because the only piece of information you really have is that this person or this principal did this action in this environment. So you don't have a lot of information, right? But it allows you to respond very quickly. So it's good for those very, very, very important reactive things, like turning on CloudTrail logging. So there are other tools out there. This is just kind of a few that we've found are useful that we've used with different customers. I encourage you to go out and check them out. That's all I have. But we've got a few minutes for questions if people want to ask some questions. I believe we've got a live microphone. It was supposed to be, oh, it's over there, about halfway down. If you've got a loud voice, you can try. If you don't, feel free to use the microphone. No questions? Oh,
I got a question for you.
Yeah, hey.
What's the best practices around experimentation and sandboxing? Because if you want to automate your infrastructure using code, but you don't know what to write yet, because there's a new AWS service comes out, you have to try it out, figure out how it works, how it needs to work. Sure. Do you have like separate environments? Like, what are the best practices?
Yeah, we found that for sandboxing, best practice is typically to have an account isolation for that, right? So typically what we'll do is we'll sort of separate that out into its own account. That way you can have elevated privileges for your developers, gives them a lot of opportunity to build stuff. With the important point that once they've figured out what they want to do, that needs to be developed into code, right? CloudFormation templates, automation, and then that's what gets delivered up into the real environments, right? Now, not everyone needs that to be a separate account, but there's not a lot of reason not to have it in a separate account, right? And the biggest challenge tends to be folks that have a lot of maybe complex connectivity back to on-premise resources. In those cases, then maybe you do it in the same VPC because you've already got those connections set up and it's really challenging to get the networking folks to open up another VPN or whatever. But just make sure that you've got very good controls around it. And try to keep it separate from production at least, right? So that tends to be the pattern there. Any other questions? Oh, we got another one coming up.
You talked about the servers being isolated. Would there be a way to create a snapshot and then power down that server so you're not incurring those charges until you have the time to?
Yeah,
research them?
you could absolutely, you could take a snapshot of the volumes, if they're EBS volumes, and power it down. A lot of folks that are doing cyber forensics, though, they like to see what's in memory. And that tends to be the reason that people do isolation and leave it up and running. If you're not concerned about what's running in memory at the time, then absolutely, you could take snapshots, terminate the instance, or shut it down if you wanted to kind of spin it back up and play with it later. But again, it tends to be that memory piece that makes you want to kind of keep it up and running. Okay, another question?
Yeah, so when you were doing that demo where it had the whole tainted thing
Yeah.
and it was isolated, did that cut off your existing SSH session that triggered the tainted?
Oh, that's a good question. Did it cut off my original SSH session? When it goes into the isolated security group, it no longer allows traffic across. Let's see if I can show it. I should have shown it right then. See, there's not a timestamp on it. But you can see I got a packet write wait. So yeah, so it will isolate, it'll shut off that existing SSH connection once I remove it from the security group, because that's up at the hypervisor layer. So we're actually pulling it at the software-defined network, so the packets can no longer get to the virtual OS anymore.
Yeah, so that's what I thought was happening. So I guess I'm curious, what's the point of even allowing SSH in the first place if it immediately gets cut off like that and terminated?
That's a good question. This is kind of a toy. So what you could do instead is potentially isolate it down to maybe just the individual IP, right? Or maybe you could, I'm not sure. That's a very good question, though. You would probably need a more refined security posture there, right? Yeah. Yes? Best practices for storing secrets. Most recently, the pattern that we've been seeing, historically the pattern that we saw was a mixture of DynamoDB and KMS. If you're using our services, obviously there's some great partner solutions out there. Vault has become kind of a very ubiquitous piece. But more recently, I've seen a lot of customers that are using the parameter store that is part of our server management service. That parameter store actually allows you to build IAM around individual parameters and parameter hierarchies, and allows you, it has baked-in encryption for those parameters using KMS. So that's a great tool if you want to use native stuff for going out and retrieving secrets. So I would say the three patterns would be roll your own with a combination of DynamoDB and KMS, partner solution, or check out parameter store. Parameter store is pretty cool. Anything else? Okay, well, thank you very much. Take care. Enjoy the rest of your day.